Okay, let's look into the question number 8, which is an F block element. Simple. To get the complete idea, let's look into the periodic table, which is already given in this paper at the starting. Okay, but I'm just displaying the colorful one so that it would be easy to understand. So let's understand what are these F block, D block. So let me indicate that this is S block. What do you mean by that? That means the outermost electrons, okay, or a valence electrons in the S orbital. Okay, then comes the P orbital, that is the P block. You people have already guessed it right, that outermost or valence electrons are in the P orbitals. This is D block. Okay, and this last one, okay, which is F block. So the question is being asked, which is the F block element, simple, SM. Okay, so the answer is correct option is B. So it was very, very simple. Just go to take the help of periodic table, which is already there in the your question paper. Just refer to that. So only your understanding should be that which are the S block, P block, F block, B block. Okay, that's all. So these are the elements so which you can easily understand. Okay, hope this is quite clear. Very, very simple. Okay, question number 9, which is correct for all solid ionic products, compound, sorry, all solid. Okay, so you need to be very careful, all solid ionic compounds. So question, okay, option A, high volatility. What do you mean by high volatility? That means the bonds are unstable, and even at the normal temperature, ambient temperature, they start getting vaporized. Okay, volatile, like petrol, diesel, etc. Definitely no, because the ionic bonds are quite strong, so this is not correct. Let's look into the second one, poor electrical conductivity. Now, here comes a very, very important one, that even though they are extremely good electrical conductors, or they are having excellent electrical conductivity when they are in aqueous solution. If they are in the solid state, they are very poor electrical conductors. Why? Because the ions are basically, please remember that the conductivity, okay, or very specifically, electrical conductivity is due to ions. And in solid state, there is no possibility, okay, of getting any ions because they're tightly bounded to each other, cation and anion. So that means if there are no free ions, that means there is no possibility of electrical conduction. So they are going to be poor electrical, okay, they will have poor electrical conductivity. So this is correct. Okay, so that means option B. But let's check up the other option, low melting point. No way. Okay, what do you mean by melting? That means basically you should be in a position to separate out the ions at the very low temperature. No, they are very, very tightly bonded. What about a good solubility in water? Again, the thing is basically that not all are extremely good. Okay, many of them are good soluble. Okay, they are highly good soluble in water, but not all. So this is again not true, but definitely For electrical conductivity, it depends on the free ions, okay? And if it is in the solid state, there is no question of getting any free ions. So that means they are going to be poor electrical conductors, okay? So this is a little bit tricky kind of this one question. You need to be very, very careful, okay? So the correct option is B. Okay. Question number 10, interesting question. Which compound has the shortest C2O bond? So we know very well, okay, the bond length. Okay, so let's recap that bond length is, okay, I'll say inversely proportional to the bond order. What does it mean? What is bond order? That means whether it is bond order means whether it is a single bond or double bond, triple bond, etc. Okay, triple bond, etc. That means higher the bond order, that means like a triple bond, the bond length will be smaller. So basically what we need to find out that what kind of a bond exists between carbon and oxygen in the four options. That's all. So let's analyze. Okay, CH3CHO, which compound we are talking about? Very, very simple. This is nothing but aldehyde. Okay, this is the aldehyde. So what kind of a bond it is? It is a double bond. Let's note it down. Then comes B, carbon monoxide. What kind of a bond it is? Okay, it's a triple bond. One of them is a dative bond, but that is all right. It's the triple one. What about C? CO2. And then D, C2H5. Okay, let me write it properly so that there is no confusion. Okay, so all these are hydrogens. So, okay, I am not showing those hydrogen, but these are all single bond. Okay, and this is double. So which one will have the smallest one? Straightforward, triple bonded, that is in the carbon monoxide. So the correct option is B. So what was the skill? Okay, the skill is to basically in a position to identify their molecular structure, okay, and identify what kind of a bond. So that's why the bond, knowing the bonds, okay, it becomes very, very important. It gives you a lot of idea, okay, about the compounds. Okay, hope this is quite clear and very, very simple.